to the Emirates Airline Terminal is the Crystal, a building owned and operated by Siemens that was designed to be one of the greenest in the world. The Crystal showcases sustainable development and contains the world's largest permanent exhibition of its kind.
We are in one of the most sustainable buildings in the world. It demonstrates innovative technologies to do with generating energy by solar and ground source heat pumps. Even the water of the toilets is being recycled. This exhibition showcases existing technologies and innovation, and also it stimulates discovery. It tries to make people imagine how their city might look by the middle of this century.
Was 2012, September 2012
okay.
was when the building was open, but for construction from ground level to opening was an 18-month process.
Wow.
Which is fast, I believe.
Yeah, that's super quick.
So there was a lot of prefabrication with the glass. It's very specialised glass on the building. So this was prefabricated in Germany, and also the steel beams that hold the structure up. These were all prefabricated, which are in the exhibition. You can see when we go later.
Okay.
This side, this plant room, this is where all the water treatment is done for the building. So because of the unique geometry of the building, it allows us with the inversion of the roof that we can capture all the rainwater.
Oh wow, okay.
So then that rainwater feeds down into these filter chambers.
Right.
So these are like inside is like almost a aluminium mesh filter to take out large pieces of debris from, you know, like leaves and things like this.
How many water can this take in?
So the water just directly passes through here and goes into a 30,000 litre tank.
There's a, wow.
So this tank is actually where you are standing at reception.
Wow.
This is below the floor tiles, this big tank. So 30,000 litre capacity here.
Yeah.
And so it's literally, as the rain's falling, it's swirling through this mesh filter and then going straight down to here. And then these pumps are connected to this tank and they bring the water back into this room on demand when water is required.
Wow.
Which is almost permanently when we're open for kitchens, for toilets. And then this is a filtration system here for the Siemens system. So they have membrane filters that are very fine, so fine that you could not push a single hair through.
You're joking.
So this is how fine the filter is, and then this cleans the water to a level where we can put it in our toilets and we can irrigate the outside land.
Wow.
So the rainwater is used for this purpose, but also we have this blue tank here. There's like a carbon filter, so if you wanted to further clean the water so we could drink the water, the carbon filter here takes all the irregularities of odour and colour and taste. And then this is a UV lamp here, so that kind of fries the final bacteria, and then the water is drinkable.
So the water comes in there first, goes down, and then it comes to the filter there.
Membrane filters,
and then these refines even more.
These two refine it so that you could drink it. But for now in this building they just do it to this level, this stage, because we don't have enough people. You know, apart from visitors.
So you haven't used these yet?
They've not used this, but the reason this is a showcase building, so maybe 80% of the things we are using, the two things that we're not using, which is this drinking water and also the, you know, if you flush like toilet waste, you can separate that.
Separate that and then clean it, refine it.
So you can do something with the solid waste where it goes to become biogas or biofuel, and then put the liquid back through this filtration system and back into the toilet, which would be black water recycling. The reason they're not doing those two things is that the original plans for the building was that it would be more occupied. We only have maybe 50 people here permanently, staff. And so I think the original plan was going to be 300 plus, because they would use all the first floor, which you'll see later. All of this would have been permanent offices. Whereas now they're using it as an event venue. We have an auditorium and we have meeting rooms for companies, businesses, universities to use. And so it's not energy
efficient.
It's not cost effective to run these two systems, but we're only 4 years old. Maybe as we move forward they may change the plans, the occupancy.
But do people still drink the one that comes from this one?
So the water, if you turn any tap on here, it will be from Thames water.
Oh wow.
So that would just be Thames water. So these three pumps that you hear making noise, they're connected to the two are connected to the tank, and one is Thames water just coming into the building for drinking. Yeah, so that would be Thames water. I probably still wouldn't drink that one just because it's in this room, but
Well, because it's upstairs, you're like, yeah, it's fine. It's
yeah, it's strange what the aesthetics around.
yeah. It's the mental map. Yeah.
So mostly this noise it's making now is the fresh water coming through the mains from Thames.
Yeah.
Because most of
So there's a pump that draws the water from Thames.
Yeah, so we're connected. I guess around the building will be our main supply for the main Thames water.
Yeah.
We hooked into that for our drinking water. But all the rainwater that's captured in the tank, we'll see another room where that is stored. And then the pumps that are in that room.
Wow, that's incredible.
So that's half of
How much do you think all of this cost?
Well, that's the only number I do know, and for everything of the building to be opened was 34 million euro. Which is a lot, but again, given that they have all these technologies going on, and they're trying to be a space building, I guess.
I thought it would be more.
Yeah, I heard that there's a big building in the city that's being renovated or refitted, and it's going to be like a project of like 80.
Wow.
So then I was like, this is cheap then, this building compared to that.
Yeah, that's like almost triple the size.
There's another room where we'll see how this operates.
Okay.
This is really the chemical dosing that would be added to the water.
Yeah, once it's more occupied and more.
So the other room you visit, this system's in place for the non-drinking water. So, but in this room, this would be connected when we do the drinking.
Yeah.
This would be turned on.
Oh wow.
And because we're not doing the water to drink at this moment, this is why this is still off.
Yeah.
The distribution board, because the building is all automated, the building is running something called Building Management System.
Yep. Yeah, BMS, yeah.
So we've got, for a size of building, we have quite a lot of data points and sensors that are feeding information to this. So there's like 3,300.
Wow.
So this is on equipment, it's on individual room spaces, through motion detection, through lux sensors. And so this all feeds into a building management system which regulates and then decides how to distribute depending on who's using a specific space at a specific time. So we also have a relay system because of course for this building not everything from solar is going to give all the electricity it needs. So we're working on a dual system. So we take what we can on each day from the PV panels and it really acts as like an equalizer, so the grid energy that feeds to the building. Of course, we have to look at the fluctuation of the grid supply and have this stay within a certain range of what comes from the PV. If this crosses paths at any time, then this, of course, will surge protect and shut down. Yes, just for the safety, and then until that's reset. And really, we're always working in this way. So, and maybe say on a winter day, on a good winter day, we take like, if we're lucky, 10 to 15% from solar. The remainder will come from the grid. But on really good summer days, I've seen us have 35% from the solar on that day. So we reduce our demand on the grid. So it's about reducing as much as possible from the grid, and then relying on site generation when you can. But it's always working really
if it's not
in this wave pattern. The grid energy, we're told, Siemens, because they funded this project, the German company Siemens.
Are they the one that supply all of these?
No, so this is the other thing. Siemens is not really for Siemens to sell themselves. Some of the systems, the building management system, the fire alarm system, lots of the automated systems are Siemens. That's where they focus their energies. But the solar panels themselves, some of the other equipment will be different companies they've collaborated with to have the best at that time of build. The converters are Siemens, which is why we've got side inverters like Siemens converters. But the automated building system, the fire system, but some of the other things we'll look at will be different providers. There's Scandinavian suppliers for the air handling unit. There's I think a British company for the ground source heating. Sanyo, I believe.
Oh, you have a ground source heating as well?
Yeah. So
does the solar panel feed the ground source heating, or is that separate?
So they're separate really, the ground source heating. I guess it does, because the energy required to pump the pumps will be supplied through electricity coming from the roof. So it does actually, they are working together. But the coefficient of this system, the ground system, is really good for us. So for every one,
you get 4 back in return.
Like 3, 4. Sometimes depending on the season, you can get up to 5. So it's worthwhile for them. So everything's kind of working with each other in that regard. So this is just the inverters for the solar, basically. And these are just all different, you know, there's so many smart meters recording, so we can look at trends and reports.
Yeah.
And this all feeds again into the building management system where you'll have tech guys on site who can override this if they have to, but for the most part it's doing...
They override it?
If for example, say you were in one of our meeting rooms and you wanted, because we have natural ventilation windows, you have 150 of those all around that can be open, and so you can just let them out and have natural ventilation, of course. But they could, if you requested your room personally you found too warm and you were having a meeting there, they can override the system and open the window. Whereas normally they would only open based on an algorithm that's set to communicate from the weather station to the building management system.
Right.
Looking at rain, direction, wind speed, temperatures, and only when this algorithm is satisfied will the windows open. Otherwise you have to personally go and make it open,
Oh, wow.
So it's very weird that they override it, but just say we have big conferences and you have 250 people in one big meeting space, and then they say we feel too warm because the chilling here, it's not air conditioned, it's passive chilled beams.
Yeah. Is what?
Passive chilled beams. Literally just like pipes, cold water pipes above.
Oh, right.
And as the heat rises, you have a natural cooling effect.
Yeah.
And you can then adjust the temperature of the flow of the water or the speed.
Yeah.
But it's very passive. Some people don't find it effective. It's very good for being sustainable and saving energy. But so sometimes the natural ventilation is needed in addition for some people.
Oh, wow.
So that's kind of how they do the cooling.